cosine 2 alpha, right? 3 different forms for cosine 2 alpha, which is fruitful because it allows us to get the half-angle formulas for sine and cosine. How about tangent? Does it have a half-angle formula?
Yes.
Sure.
Yes.
So, yeah. What's the best way of writing that? I can say sine squared over cosine squared, right? Is tangent squared, so I'm going to say tangent squared alpha is sine squared alpha over cosine squared alpha, which is going to be, yeah, so so I can just put a 2 here, right? And a 2 here, multiply the top and the bottom by 2, and then I get, for sine, twice sine squared is 1 minus cosine 2 alpha, and twice cosine squared is 1 plus cosine 2 alpha. And so that's tangent squared of half of 2 alpha, right? So alpha is half of 2 alpha, that's why this is a half-angle formula. So if I know cosine 2 alpha and want to compute tan 2 alpha, sorry, tan alpha, I can use this formula, which I guess we would say tan alpha is then the square root of that. And I guess it could be positive or negative. Is it gonna? Yeah, do we need the plus or minus here? Let's see. Yeah, because we take a square root. I mean, this is a positive number, right? Because cosine of anything is less than 1, so 1 minus something less than 1 is positive. 1 plus something between negative 1 and 1 is positive. So it's going to be a positive divided by a positive there, which is positive. But when I take the square root, I'm going to get tan alpha, which could be negative. So I need to use a plus or minus again. So I get this 1 minus cosine 2 alpha over 1 plus cosine 2 alpha, which is a little gnarly looking, isn't it? You got this square root with a complicated radicand. But here's what we can do. We've got the square root of 1 minus cosine 2 alpha over 1 plus cosine 2 alpha. Any ideas? Is your Pythagorean sense tingling at this stage? Right, that's the same thing when we were, that's right. So the suggestion is we multiply by 1 in the form of 1 minus cosine 2 alpha divided by 1 minus, so I'm going to do that. I'm going to put it all under the radical. So I'm going to multiply by 1 under the radical and write 1 in this well-considered way, as suggested, right? That if I multiply by 1 in that form, then what happens on the top? So this is tan alpha. I guess I should write the plus or minus outside, right? But on the top, I'm going to get square root of 1 minus cosine alpha squared. Well, that's the square root of a square. That's like an absolute value, right? I say that's like an absolute value, right? But is that clear? That so let's have a little note here. If you take the positive square root of the square of x, is that x? Only if x is positive, right? Because the positive square root has got to be positive. So in general, that will be the absolute value of x. If x is positive, then yeah, it's just x. If x is negative, then it's the opposite of x. So that's why we're gonna need the absolute value. So how about downstairs? I got another square root still, right? I'm splitting up the square root of the ratio is the ratio of square roots, right? So that works out. But downstairs, I'm gonna get, that was my whole goal in doing this, is I get 1 minus cosine squared. It's a difference of squares situation, right? And what do you know about 1 minus cosine squared on a Tuesday? That's sine squared, right? That's the Pythagorean identity. So upstairs, I get plus or minus the absolute value of 1 minus cosine 2 alpha. Oh, did I forget the 2 here? I did, didn't I? Don't forget your 2 here. 2 alpha. And downstairs, I'm going to have the square root of, well, it's going to be the square root of sine squared and the positive square root, so that's going to be the absolute value of sine 2 alpha. Right, so that's the beauty of the Pythagorean identity here, is that instead of having a difference of squares, we have a single square, and the square root of that square is just a thing. Well, the positive square root would be the absolute value. So now we have this little problem with the absolute value, right? So this is plus or minus the absolute value of 1 minus cosine 2 alpha over sine 2 alpha. Now, plus or minus an absolute value. So the numerator is always going to be positive, right? Why? Well, cosine is always less than 1, right? And bigger than negative 1. But always less than 1. So if you subtract something less than 1 from 1, you get a positive number, right? Or 0, I suppose, if you get 0. If it's 1, cosine 2 alpha is 1. But never anything negative, right? How about the denominator? Well, the denominator has the sine SIGN of 2 alpha. So the sine of 2 alpha is the same as the sine of tan alpha. I'm going to say this is true.
Sine?
Yeah, sine with a G. That's either plus or minus, right?
Mm-hmm.
Is that true? Let me put a question mark here. Well, in what quadrants is tan positive? Positive alpha in quadrant 1 or quadrant 3, right?
Yeah.
Quadrants 2 and 4, it's negative. So sine 2 alpha is positive. Let's write greater than 0, okay? If 2 alpha is in where? Quadrants 1 or 2? Right, where the y coordinate on the unit circle is positive. If you're in quadrants 1 or 2, that's the sign, right? So if twice alpha is in quadrants 1 or 2, what does that mean about alpha? Let's dial it up. I'm uncertain about this, honestly. So if 2 alpha is in 1 or 2, oh yeah, then alpha is in quadrant 1, right? So say 2 alpha is over here, then half of it will be over here, right? In quadrant 1. Provided that bisects the angle, which I tried to do. And that's going to be true no matter where in quadrant 2. And certainly if 2 alpha is in quadrant 1, then so is alpha, right? So what, do we have to worry about quadrant 3? Well, not really. So let's just make a long story short and say, this is always equal to 1 minus cosine 2 alpha over sine 2 alpha. It agrees, right? So the absolute value, we can drop the plus or minus at the same time and just say, look, tan alpha is always just this very simple expression, 1 minus cosine 2 alpha over sine 2 alpha, which is a much simpler expression for this, right? Cosine 2 alpha on the top over sine 2 alpha on the bottom. I think there's another one too. Shall we do that one? Let's use this space over here. All right, so if we have tan alpha is equal to 1 minus cosine 2 alpha, this is why it's called the half angle formula, because we're getting tan of half of twice alpha here, right? In terms of twice alpha.